I think this is backwards.
Okay. So you learned about angles in geometry, but we need to talk about angles in a little more general sense. There are types of angles you never dealt with. You never dealt with like a negative angle last year. What?
Yeah, that's a nice game.
Well, thank you.
It smells like
It's from Mr. McGowan.
Okay,
What?
you can have
So yeah, like last year, angles couldn't be negative. They couldn't be like too big. And so we need to take a look at the actual definition of an angle and then kind of see how to work with this. This is going to lead us into some more involved things with trig. I feel like yesterday someone asked, well, why do the triangles always have to be right triangles? After we go through some of this stuff, we're going to get into, we don't actually need things to be right triangles to work with some trig ideas. So, angles in standard position. This is why I want to do this as a PowerPoint. We have a ray over here. To create an angle, we are going to take our ray and we are going to spin it around the initial point. And it's going to spin.
Whoa!
That's why we had to do it like this.
It's like a clock.
We have an angle.
Are you recording?
Yes.
Hi.
Oh my gosh. And we've got an angle theta.
Recording audio?
Maybe. Okay. Now we need to start writing. We are only going to deal for right now with angles in what we call standard position. An angle is in standard position. We're on section 9.2. What page is that?
7.
Oh, good.
Page 7.
Page 7.
Okay. An angle's in standard position if its vertex is at the origin and one ray is on the positive x-axis. The ray I'm starting with is on the positive x-axis. I spun and ended with another ray. We'll give those rays a name in just a moment.
So we should draw that too?
Everything that's in here should end up in your notes. Yep. You will want that picture because we're going to talk about specific parts of that diagram.
I can remember.
An angle is in standard position if its vertex is at the origin and one ray, this one over here, is on the positive part of the x-axis. So I've got that vertex in the middle. The ray. Thank you. The ray that is on the positive part of the x-axis, we call the initial side, or sometimes the initial ray of the angle. We should be right. And I feel like if I push this, it's going to, yep, that's the initial side.
Oh.
The other one, where the angle ends, where kind of the ray has spun to, we call the terminal side, the ending side. The ray that rotates about the vertex that ends somewhere over here is called the terminal side. And if I push this again, I bet it'll label it, yep, terminal side. We will be using these words as we talk about various types of angles. Every angle has an initial side and has a terminal side. And the angle itself is related to how much we're rotating. It's not like the length of a side, it's how much we're rotating. Another moment to finish writing a couple things. Question, Casey?
No. No. I just like totally do not see the middle part.
The middle part. Oh, the angle.
No, like the middle bullet. Like I just
Oh,
skipped
yep,
right.
there are 3 bullet points on the board right now.
Oh,
Wait, there
I didn't
are?
see that either.
Oh my goodness.
I'm just kidding.
I think you're on something.
Okay, moving on.
Don't even all.
I was hoping to be able to do this. I might not be able to, though, tomorrow if we're going to continue like this. And then I think they might be a little annoyed at you. The people on the field trip.
Wait,
Okay.
wait. Why
I'm
is
a
there,
bird
why
now.
are these people in New York?
Don't worry about that right now. Okay, next.
Is it my building Trump Tower?
We do need to get through this.
We're trying to close all those lines.
Wait, you had to draw.
Hold on.
I'm a pass.
Oh my goodness.
Thanks.
We're making this way more difficult than it needs to be. Still in that top section. We can talk about positive angles and we can talk about negative angles. In a positive angle, the terminal ray is rotated counterclockwise. Watch carefully. That is a positive angle if we spin in that direction. So maybe draw a little diagram. Show how you're spinning it by putting a little arc mark there with the arrow at the end that shows where we started the angle and where we spun it to. And we would say that an angle spun in that direction is a positive angle. And I might as well get the other one in there as well. This is what you didn't talk about last year. We can have a negative angle. If theta is a negative angle, the terminal ray was rotated clockwise. So watch this one, how it spins.
Fucker.
How do you know that we didn't start there and then go?
Because we're always starting on the positive x-axis. And then how do I know like we spun like this rather than like this?
Oh, there's
Because
an arrow.
the arrow has to be in there. There is no other way you would know that. Which means in a moment when we start drawing these angles, you're going to have to make sure you put that little marking in there so I know how things were spun. And this is the last of the notes that are going to go in that top section. You won't have to try to cram anything else. That is okay, because we are done with that part.
No.
Bless you. Are we ready? We're waiting.
We're just writing.
Wait. You couldn't possibly take that home.
Just worry about yourself, Kevin. Okay, so the first thing we need to look at is drawing angles in standard position. Do you already have little axes in there? Okay, what I'd like you to do is just draw, nothing else, just draw some small axes below A, B, C, D. We're going to do these four together. You're going to try a few on your own in a moment. But right now, just start with some axes.
I wish I was on the island of Mr. Wicks.
Okay, hush, Kevin. We are now asked to draw these angles in standard position. Well, 36 degrees. How much? First of all, what direction will 36 degrees spin?
Counterclockwise.
Counterclockwise or clockwise?
Counterclockwise.
Because it's positive. Now, how far are we going to go?
Very little.
Well, obviously 36, but like,
bit. Not that far.
will it go up to here?
No.
If we did go up to the vertical line, what would that angle have been?
No.
Okay, so we're going to try to figure out things relative to that. 36 degrees, approximately like this. Your drawings are not going to be 100% accurate, that's okay. What I do need, though, is 36 degrees to be drawn in quadrant 1. I do need to see that marking showing how things were getting spun, starting on the positive axis, pointing in a counterclockwise direction. When I ask you to draw an angle in standard position, you'll start with axes, you'll have the initial side on the positive x-axis, and then you'll spin and show how you were spinning with a little symbol like that to show where you're ending. Does that make sense? 315 degrees. So hopefully you remember from Algebra 1, quadrant 1, 2, 3, 4, things like that.
Yes.
Which of those quadrants?
4.
We think 4. Okay, because up here is 90. What's this?
180.
180. What's this? What's this? Yeah, so I know it's got to be between 270 and 360. 315, you're going to draw it like that. It is really important that the marking is the one that goes all the way around. If you went the other way, you'd be talking about a much smaller and negative angle. So do make sure you're getting these drawings again with that rotation marking in the notes.
Are these going to be like things on like Rubik's Cube?
You'll have a quiz on this eventually. There's obviously a lot more to this. We just started this section. Paul.
How far are we going to get before break?
Through 9.2.
How many quizzes?
One quiz. Let's keep going with this though.
Okay.
Negative 150 degrees. What does the negative do to how I spin?
Clockwise.
It's now going to spin clockwise. Well, where will we end up? What quadrant?
3.
3.
I'm so sorry.
So let's get that drawing in there. And when you're done, try letter D on your own. I think you can probably figure that one out.
Are the numbers required?
No, I think if you just have the diagram, initial rate, terminal rate, and the marking for how it was spun, that's good enough.
Oh.
Oh, maybe we won't do some more practice with this. That's okay.
This was old this morning.
Negative 225 degrees. Who are we going to pick on? Olivia, what quadrant did you end in?
Quadrant 2.
Quadrant 2? Yeah, looks good. Because this would be negative 90. This is negative 180. This is negative 270. So it's like actually exactly halfway between negative 180, negative 225. You'll end up about there. Do you follow how this is working so far? Next, we have these things called coterminal angles. The definition is these are angles in standard position that have the same terminal side. Copy it down and I'll show you exactly what I mean by that. And I think this is probably where we'll end for today. Coterminal angles are angles that in standard position have the same terminal side. Question?
Does that mean that it should be 360 degrees?
That's going to have something to do with it. Coterminal angles are angles in standard position that have the same terminal side. No, you're actually not going to have to draw them. You're just going to watch. So, I am telling you, and I'll show you exactly why, I'm telling you that 100 degrees, negative 260 degrees, 460 degrees, that's going to be weird, and negative 620 degrees, that's also going to be weird, are coterminal. Watch why. 40 degrees, not 40 degrees, 100 degrees, looks like that. Look at what negative 260 degrees looks like.
Same thing.
It is not the same thing. Here's why. Well, here's why. 100 degrees, remember the angle isn't just where you start and where you end up. It's how you got there. I'm spinning in this direction, in a counterclockwise direction, to get to 100 degrees. I'm spinning much more in a clockwise direction to get to negative 260. They end in the same place. That's why it's so important that you show how you're getting there. Watch what happens. What do you think is going to happen with 460?
Overlap.
It's like a double lap.
Like it's going to go all the way around and like a little more? Watch. And a little more. And I couldn't get I couldn't figure out how to do that nicely, so I just going to do that by hand. And negative 620 degrees.
Oh, here comes another. Ah.
Do you get what it means to be coterminal?
Yeah, but I probably.
That seems difficult.
So to actually calculate that, though, we're going to deal with that next class.
Okay.
We have a lot more to do with this. I just wanted you to see what it means for things to be coterminal. I'm going to show this